more examples here. So, sodium chloride and potassium bromide. So again, let's double displace the names. Oops, sorry about that. Sodium chloride, potassium bromide. That's going to get me sodium bromide, because I've traded, and potassium chloride. All right, sodium bromide and potassium chloride. Well, we already checked sodium chloride. It's right down in there. It's aqueous. And now if I check potassium bromide, but if you recall from the other day, all potassiums are aqueous. Bromide is right there. It's right there on the side. You'll notice it is aqueous. So that's aqueous. And now let's check the products. Sodium bromide. Again, sodium is all aqueous. So sodium bromide will be aqueous. Whoops, that's not the right one. Right there. So it's aqueous. And again, potassium chloride. Again, all aqueous. All right, there it is right there on the edge. All aqueous. So, you'll notice in this reaction, there is no solid. So, in this case, no reaction occurs. Okay? There is no visible precipitate. All right? And why is that? Basically because there are no solids. No solids as the product. Okay? So, if we have all aqueous, 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 no reaction occurs. It is a failed double displacement reaction. Let's do one more example, and then I'll give you some homework. Okay. So, let's trade the partners around. Sodium nitrate, because it went with the nitrate. Lead 2 sulfate. Sulfate. Let's check them. Sodium sulfate. All right? Sodium, all aqueous. Sulfate's way down here. You can see there, aqueous. Aqueous. Lead 2 nitrate. Got to move up a little bit so I can see the nitrate. Nitrate's right there. Work my way down to lead 2. I've got it in the corner of the box. There it is. Also aqueous. Sodium nitrate. Again, all sodiums. Aqueous, aqueous, aqueous. Even sodium. Oops, that's not the right box. Sodium nitrate's right there below that one. Aqueous. Aqueous. Lead sulfate. Lead sulfate. You'll notice it makes a nice little rectangle when we pick the right spots, right? Just above there, and that's a solid. Solid. So, in this case, yes, we have a precipitate. We have a solid. It's going to form a solid in the reaction. Let's now complete the balanced chemical equation. Again, you need the periodic table in the back of the chart so you can see what's happening. Na and sulfate, SO4, and sulfate has a charge of 2, so there it is there. Aqueous plus lead, Pb, lead 2, so we know the charge is 2, NO3, nitrate. Nitrate has a charge of 1, so we need brackets to cross over the 2, and it is aqueous. Sodium nitrate, Na, charge of 1, NO3, charge of 1, so that's done. Aqueous. And lead, Pb, charge of 2, sulfate, SO4, charge of 2, and so that is done as well, 2 and 2, and there's our solid. Now, we didn't do this in the first example, but the last thing we have to do is balance this. All right? Notice, if we keep our polyatomic ions together, all right? If we keep our polyatomic ions together, there's a sulfate and there's a sulfate. It's balanced. There's the lead right there, 1, and there's the lead. It's balanced. Sodium, there's 2 and there's 1, so I need a 2. And now if we look at the nitrates, there's 2, and because of the coefficient that we put here, there's already 2. So right there, that's balanced. Again, here is the precipitate. Yes, we have a precipitate. PPT is the short form for precipitate. All right? Okay. There are some questions for you to continue with. And then I believe these are the questions that are on page 57 out of the textbook. And then there's also a worksheet that you can work on at this point. All right. Those are double displacement reactions. If you have any questions, ask me tomorrow when I get back. All right?